Hi everyone. Hope you're all doing very good. So we have learned about the Department of Radiology, then about the different courses, the career opportunities, about the history of X-rays, and today we are going to learn about the production of X-rays. So we will be doing videos based on radiology. We will try to cover almost all the topics. So these videos will be really helpful for the students as well as for the practicing radiographers, where you can brushen up what you have learned. Okay, so we will also try to include new inventions and technologies. So please watch the videos. I hope it will really be helpful for you. In this video, we will be discussing about the production of X-rays. How X-rays are produced. X-rays are produced when fast-moving electrons are stopped with the help of a target. When the electrons are stopped by using a target, the kinetic energy of the moving electron is converted into 1% of X-ray and 99% of heat. In this image, you can see the picture of an X-ray tube. So here you can see a tungsten filament which acts as cathode. Then we have a tungsten target which is the anode. The tungsten filament is heated to a very high temperature, as a result of which electrons are ejected from the tungsten, and with the help of a high voltage, it is accelerated towards the target or the anode. Now, as the electrons hit the target, the energy is released in the form of X-rays and heat. What are the conditions necessary for the production of X-rays? So for X-ray production, we need an electron source. In the X-ray tube, the tungsten filament acts as an electron source. Then we need a target, which is the anode, in order to stop the electrons. Thirdly, we need a high voltage supply so as to accelerate the electrons. Then, one of the most important thing is you need to maintain a vacuum condition inside the X-ray tube. Now, why this vacuum condition has to be maintained? If there is no vacuum condition inside the X-ray tube, the electrons will interact with the particles in the X-ray tube and result in ionizations. And this will result in other interactions, and that may affect the production of X-rays. Then we have tube insert and housing. Now, what are the different types of X-ray production? Generally, there are two types of X-ray production. The first one is Bremsstrahlung radiation, and the second one is characteristic radiation. Now, what is a Bremsstrahlung radiation? So the other name of Bremsstrahlung radiation is braking radiation. It describes the radiation which is emitted when electrons are decelerated or braked. That means Bremsstrahlung is an electromagnetic radiation that is produced by the deceleration of a charged particle. So here the charged particle is electron, and this is deflected by another charged particle, which is the nucleus. The Brems's radiation occurs when electrons passes near to the nucleus. When electron passes close to the nucleus, the original path of the electron is deflected, and thereby it results in the release of kinetic energy that is converted into Bremsstrahlung radiation. The amount of Bremsstrahlung radiation is determined by the distance between the bombarding electron and the nucleus. If the distance is small, then the Coulombic force is strong, and this results in high energy X-rays. But the probability of occurring this type of interaction is lower in Brem's radiation. If the distance is large, then the Coulombic force is weak, and the X-rays produced is that of low energy. And this type of interaction has greater probability. Now, if the electrons hits the nucleus directly, the electron will lose all of its kinetic energy, but this type of interaction will account to only 5%. Let's see how a Bremsstrahlung radiation occurs. Now, this is an atom in the target. So this is the nucleus, the center portion of the atom. The nucleus consists of protons and neutrons. Here protons are positively charged, neutrons are neutral particles. So the net charge of the nucleus is positive. Now surrounding the nucleus we have shells, and on the shells we have electrons. So the shell close to the nucleus is the K shell. Then we have L shell, M shell. Now what happens in Bremsstrahlung radiation? In Bremsstrahlung radiation, the electron or the incoming electron moves close to the nucleus. As the electron moves close to the nucleus, due to the force of attraction between the negatively charged electron and the positively charged nucleus, the original path of the electron is deviated. So this deviation results in the loss of kinetic energy of the electron, and this kinetic energy is converted into 1% X-ray and 99% heat. So this is the original path of the electron. Because of the force of the attraction between negatively charged electron and positively charged nucleus, the path of the electron is deviated and there is loss of kinetic energy, and this loss of kinetic energy is converted into X-rays and heat. So this is what Bremsstrahlung radiation is all about. So this is how Brems radiation is produced. So we get 1% of X-ray and 99% of heat. Now let's see how X-rays are produced in characteristic radiation. In characteristic radiation, the incoming electron collide with an orbital electron or interact with an orbital electron. So the incoming electron interact with the orbital electron of the K shell. Now what happens when the electron bombard with an orbital electron? This electron is ejected from its position. So this is what happens. The incoming electrons collides with an orbital electron and both the electrons are ejected from the atom. Now a vacancy is generated in the K shell. So this vacancy will be filled by the electron from the nearest shell, that is the shell close to K shell is L shell. So the electron from the L shell moves to K shell. So as a result of the difference between the binding energy of the electron in the K shell and the binding energy of the electron in the L shell, there is release of energy in the form of X-rays. Now if we see this, electron from the L shell moves to K shell. Now a vacancy is generated in L shell. Now this vacancy in L shell is filled by the electron from M shell. So this process continues. So this is how characteristic X-rays are produced. Characteristic radiation, as I said, the X-ray photons are produced as a result of the difference in the binding energy of the shells. In X-ray tube, as a target material, we use tungsten. Now, if we consider a tungsten atom, the binding energy in the K shell is 69.5 and the binding energy of the L shell is 10.2. So what will be the difference of the binding energy? That is represented by the equation H nu is equal to EK minus EL, where EK is the binding energy of the K shell and EL is the binding energy of the L shell. So the difference, you get it as 59.3. That is 69.5 minus 10.2 and the result is 59.3. So this is the energy difference between the binding energy of the K shell and the binding energy of the L shell. So based on this energy, the X-ray photons are produced. Thank you so much for watching the video. If you find this video useful, please subscribe and share. So that was all about the production of X-rays.